All right, I think we can even start a little bit ahead of time. Okay, the recording is good? Okay. Before we get into the talk, I would like to get a feeling for the audience and for like your experience level with GraphQL so far. So, first question, who has heard of GraphQL before? Raise your hand. Okay, I think I will ask this the other way around. Who has not heard of GraphQL yet? Who has really no idea what it is? All right, cool. Still have a couple of people who haven't heard of GraphQL. If you had asked this like a year ago at a conference, then a couple of more people wouldn't have heard of it. By now, because it's such a hype, I think a lot of people have already heard of it. Next question, who is using GraphQL? Like in production, in a production application? All right, we have a couple of people who are using it. So my talk today is about GraphQL, but more precisely about GraphQL subscriptions, which is a feature inside GraphQL to build real-time applications. And I have a small app prepared, which I'm going to implement later on, like a real-time chat, so we can actually see GraphQL subscriptions in action. All right, first, a couple of words about myself. So my name is NICOLAS BURK. I work at a small startup in Berlin that is called GraphQL, and we're building a backend development platform for GraphQL. So you could somewhat think of it as a backend as a service, but we're also offering an opportunity for you to self-host the service. So it's not quite a backend as a service, it's a bit more flexible. You can design the APIs in the way you want, so it's not quite the same as, for example, Firebase, if you've used that before. All right, so before we get into the actual topic, GraphQL subscriptions, I want to make sure that everybody's on the same page about GraphQL and they know what I'm talking about. So I'll give a brief introduction into GraphQL and introduce you to the main concepts. Then we'll talk about GraphQL subscriptions, so the real-time feature for GraphQL. And then finally, I'm going to have the demo where I'm going to implement the real-time chat. So let's start with the GraphQL introduction. And the big question, what is GraphQL? So in a couple of words, it's really just an API standard that was developed and open sourced by Facebook. It's roughly 2 years old, so I think it was about 2 years ago that Facebook open sourced the GraphQL specification. And it's essentially a query language for APIs. And that's a really key part to understand, that despite the fact that it shares the same suffix with SQL, so it's also a query language, it doesn't have anything to do with databases. So it's not a database technology, it's an API technology. And that's a very common misconception about GraphQL, that you would think because it's a query language, of course, it has something to do with databases. It has not. It's completely database agnostic. It doesn't care where the data is actually coming from. And yeah, so it's a query language for APIs. And it essentially provides a declarative way of fetching and updating data, a declarative way of working with an API. So rather than having like multiple REST endpoints that would return like fixed data structures, with GraphQL you usually only have one single endpoint that returns flexible data structure. And we'll see in a bit how this works. And one reason why GraphQL goes so nicely together with React is that they are both declarative, right? React is a declarative library for building user interfaces. GraphQL is a declarative way for working with APIs. All right, let's consider an example and really understand what is the difference between REST and GraphQL, because they kind of sit on the same level inside your stack, except that GraphQL is a bit more flexible, so you could use GraphQL as an alternative to REST and completely replace it, but you could also use it as a complement, so you could use it on top of a REST API, for example, or on top of like multiple microservices which your apps might have. So here is a simple profile screen for a blogging application, where on top of the profile screen, we want to render the first name of the user, then we want to display all the posts of that user, and then finally, we also want to display the last 3 followers of that user. So this is what the profile screen looks like that we want to display. So how would we tackle this situation with a REST API? With a REST API, we would typically have 3 different endpoints. The first one would be /users/a user ID. So this would return information about one particular user with a given ID. Then we would have the /users/id/posts endpoint, where we could retrieve all the posts that that user has ever created. And then finally, we would have the users/ID/followers endpoint, and this really would be the endpoint that would give us all the followers for that particular user. So if we now implement the screen that we saw before, we would have to hit all these three REST endpoints. So the first step would be to fetch the user data so that we can render the first name of the user on top of the screen. So we would hit the /users/ID endpoint with a given ID, and then we would get some response from the server that contains all the data for that user. But notice that at this point already, the /users endpoint might return more information than is actually needed inside the app. This means we're downloading data that is not required, that is completely unnecessary, we don't need it right now, but we're still actually retrieving it from the server. But at least we get the user's first name, so we can render it on the profile screen. Next, we would hit the user's ID post endpoint to get all the posts. And here, depending on how your API is designed, again, we are not only retrieving all the posts, but not only the titles of the posts, but we're also retrieving additional information about each post. So again, we're downloading a lot of information that we don't need. And this really isn't a desirable situation if you have huge REST endpoints. If you've seen, for example, the REST API from GitHub, for each endpoint, they return a huge blob of JSON, and this is just a lot of data that you don't need, and you really want to be more specific in what the server is going to return. But again, at least we receive all the titles from the server, so now we can display that on the screen. And then we've exactly the same game for the followers again, where we're hitting the user's ID/followers endpoint, and this time we're downloading all the followers and display them on the profile screen. So this is how we would typically tackle this situation with REST. Of course, there are ways to design your REST API in a more convenient way for the front end, so that you actually have like one endpoint that would return all this data. But if you want to iterate on your designs, and now you have changing requirements on the front end, and you really want to be capable to actually iterate quickly, then you cannot really adjust the API when the data requirements change every time, because every time you would have to go to your backend engineers and tell them, hey, can you give me this data in this for this API endpoint as well? I'm sure like a lot of people of you have actually already experienced this kind of situation where you had to talk to the server engineers and ask for the data, because it's just too inconvenient if you have to make like multiple round trips to the server to get the data that you need. All right, so what does this situation look like with GraphQL? With GraphQL, so the big difference I mentioned in the beginning is that with GraphQL, you only have a single endpoint for your API. And the way how this works then is that the client sends over a query that is describing the data requirements that the client has at this point in time. And the server is going to resolve that query and respond with exactly that data. So instead of only like having multiple REST endpoints with fixed data structures, you only have one endpoint with flexible data structures. So here we would send a query that could look like this. We are asking for a specific user, and then inside the query we are specifying what's called the selection set. And there we can clearly specify what is the data that we want to have. And here we just ask for the user, the name, the post with their titles, the last 3 followers. So instead of downloading all the followers, we are only downloading the last 3, and the name. And this is what the server is going to respond with. So again, a blob of JSON. The root field of that is called data, and that is specified in the GraphQL specification. So every GraphQL server response always has to have this root field, data, and we're going to see this a couple of times in the following slides and in the demo as well. And then we actually receive exactly the payload that we need to render the right information on the screen. So here is like the classic example when you compare REST with GraphQL. You just send over a query, and the server is going to resolve that query for you. All right, so now that we have the example, we can actually talk a bit about the theory behind it and the major concepts. And here I want to start by introducing 2 concepts, which are the queries and mutations. And we start with queries. All right, so a query is sent by the client to the server, and the server is going to resolve that query. So we can only read data with queries. We're only fetching data with queries. And let's look at the main components of a query. What are all these words that we see there on the screen? So at first, we have the operation type. So this could be either query, mutation, or subscription, as we're going to see later on. Query is actually the default operation type. So here I could also leave it out, but I have it explicitly mentioned. And then we've got the operation name, which is also optional. You're not required to provide an operation name. Then we have a number of fields that specify what is the data that we actually want to have. The first field is called the root field of the query, and the whole collection of fields is called the selection set. So here is here we specify the data which we want to have returned from the server. The potential response for this particular query, again, could look like this. So we have the root field again, which is called data, and then what's really nice about GraphQL is that the shape of the query always also determines the shape of the response. So you can somewhat think of a GraphQL query as an empty JSON object, a JSON object that only specifies keys, and you send over that empty JSON object to the server, and the server is going to fill in all the values for you. Then we also have the concept of mutations, because most of the time when you're working with an API, you not only want to download data, you also want to be able to change the data in the backend. And that in GraphQL you're doing with mutations. And mutations follow the exact same syntactical structure as queries, except that the very first word, the keyword, the operation type, has to be mutation, but everything else is exactly the same. So here we have the root field, which is called create message, and then we are also specifying the ID. And the response from the server will look exactly the same again. It just fills in the values for these fields. All right, so now we get into the first practical part, where I'm going to go ahead and create a GraphQL server, and then we're going to explore that server inside a GraphQL playground, which is basically a GraphQL IDE. You can think of this. All right, so here I'm in my startup project, and the way how I'm going to create the GraphQL server is with the GraphQL CLI. So the command for that is GraphQL init, and then the GraphQL is just the folder where I want to put all the files that are related to my GraphQL server. So now I'm creating my GraphQL server. I'll just start with a new blank project. And now we already have a GraphQL server in our backend, or we already have now a GraphQL server available under this API endpoint. And the first thing which we have to do now is we have to configure the data model for the application. So the way how we do this is we go into the GraphQL directory, which was just created. Here we have got a code folder, which I'll talk about in a bit. Then we've got the GraphQL.yaml file, and the GraphQL.yaml file is essentially the configuration file for your GraphQL backend, and then the types.graphql file that contains your data model. And here I want to make changes to the data model. So we start by providing this default user type, which I'm going to get rid of, and replace it with the data model for the chat application that I'm going to build later on. So here we have a person type and a message type. They all have a unique ID, a created at and updated at field, which are going to be maintained by GraphQL, so read only for me as a developer. And then I've got the name and the messages of the person, and the messages effectively represent a one-to-many relationship between the person and the message type. Okay, so now I have to go and apply these changes to my GraphQL project, and I can do that with the GraphQL deploy command. And because I deleted the user type, I also have to pass the force option here. All right, so now we see that a new type with the name person is created, and a new type with the name message is created. And what this effectively means for our GraphQL server is that our GraphQL server now exposes CRUD operations for these two types. So now I can send I could potentially send a create person mutation to the backend, and it would create one person in the database. And that's precisely what we're going to do right now with a GraphQL playground. So the short form for GraphQL is just GC. And here I'm going to start up my playground. I'm going to switch to light mode. And I will first go ahead and start by sending an all messages query to ask for all the messages which we currently have in the database. I don't think that's possible here, unfortunately. So what we can do actually, we can also just use the GraphQL endpoint that we saw before and paste it into the address bar of a browser, and there I can go and increase the font size. So I think we'll do that. It's probably a bit easier. All right, so here we have the same GraphQL playground, and I can send again the all messages query. I'll ask for the text of each message, and then who sent it by name. That's probably better. All right, so the server responds with an empty array of messages, which is kind of logical because we haven't created any messages yet. So before we go and create messages, let's also send an all persons query to ask for all the persons in the database, and as expected, also an empty array. So now we can go ahead and send our first mutation. So now we have to specify the operation type to tell the server that this is not a query. And we're using the create person mutation where we provide the name for the person. Let's just call her Sarah. We're asking for the ID in return, and now this person was created. We're getting the ID, which was generated on the server. And if we go back to the all persons query, we'll actually see that this person is now being returned. What we'll do next is we'll send a message in the name of Sarah. So we'll use the create message mutation. The text is just going to be hi of that message, and then we have to provide her ID, which I just copied. And let's go ahead and send this. So now a message was created in the name of Sarah. So now if I send the all messages query again, we expect that we get this message returned, and we'll see that it was sent by Sarah. And this is exactly what the server is responding with. All right, do we have a good feeling about queries and mutations so far? Cool. Then let's continue with the slides. And with one more concept which I want to introduce before we get into subscriptions, and that is query variables. So when I just provided the parameters for the queries and mutations which I just sent, I hard-coded the values, but you also want to be able to pass variables inside there. So the way how you can do this is up here, right next to the operation name, you just specify what kind of variables you want to be able to pass into that query, and then you just replace the hard-coded value with the variable. And this, of course, also works for mutations. So here you could just go and add the text as a variable and also replace this right there. So that's the concept of query variables. Inside a playground, you'll actually have this little pane here in the bottom where you can add them, and I'll quickly show that. So here you have the query variables, which you can expand. And if I want to create a second message by Sarah here, create message, and I'll just pass the text, and I make it a required argument, and we'll use the text as an argument. And now the query variables, with the auto-completion, I actually only have to type the T, and it auto-completes, and then we can provide the second message, just send it, and back to the all persons, all messages query, we now have 2 messages from Sarah. All right, so far for the GraphQL introduction. Let's now talk about GraphQL subscriptions, the real-time mechanism of GraphQL. So GraphQL subscriptions allow you to implement event-based real-time updates in your application. And it works in the way that as a client, you have to send over a subscription query to the server. And again, a subscription query has the exact same syntax as a regular query and a mutation, except that the operation type in the beginning needs to be subscription instead of query or mutation. So you have to specify this is a subscription query by just specifying the operation type. But then you can use the exact same syntax as for queries and mutations. And they're usually implemented on the client side with WebSockets. So in the example which I'm going to show, I'm using Apollo Client, which is a GraphQL client library. And they're implementing this effectively with WebSockets. So the way how this works is that the client would send over the subscription query to the server. And here we just specify that we are interested in all the events relating to the type message. And in the GraphQL system, this is just when a new message is created or an existing message is updated or deleted. So these three kinds of events we have with GraphQL, and we would send over this query to tell the server that we are interested in all the three events. So the node and the text is just the way how we structure the API. This essentially gives you the text of a new message which was created, or if it was updated, it will give you the updated text. And if the message was actually deleted, it'll also be possible to retrieve the previous values, or if it was updated, you can learn which are the fields of the message which have been updated. So let's assume that that the server is now receiving a couple of mutations. So what would then happen is, because we have a steady connection between the client and the server, so we break out this typical request-response cycle that we have with queries and mutations, and instead we have like a steady connection between the client and the server, and the server is going to push the requested data to the client whenever a create message mutation occurs. So here it will just send over the query, the data from the created messages. Let's also see how this works in a playground, because you can also test your subscriptions inside a playground. So here I'm going to create a new tab again. And I'll use the same subscription that we saw on the slide. I'll click the play button. And rather than seeing the response right away, we just see this loading indicator, because we're now waiting for the events to happen. And if I go and create another message, as we did before, subscriptions are great. We sent this, and now in the tab here, we expect the data to occur. All right, let's maybe try that again. There you are. It's sometimes a little bit buggy in the playground, but we just received the subscriptions from the second mutation here. All right, so now we have a good feeling about subscriptions as well. So now we can actually take a look at the example application that I want to build. So let me quickly introduce to the setup of this application. So it's going to be a real-time chat, and we're using React and Apollo for this. Here is what the stack looks like. So we've got the front-end application, which I just created with create React app. So very, very simple. And then inside there, we have the Apollo client, which is completely responsible for all the API interactions. So it's going to be responsible for sending queries, parsing the data, managing the cache, all of that. And then we have the GraphQL server, which is provided by GraphQL and provides, of course, a GraphQL API. A quick note about GraphQL clients, because GraphQL client libraries are kind of an important concept when you're working with GraphQL on the front end. So in general, GraphQL clients provide like a nice API for sending queries and mutations. So rather than having to use fetch and put your whole query into a gigantic string, you can essentially use the nice API that a GraphQL client library is going to provide, and it's going to make the API interaction a whole lot easier for you. Most of the GraphQL clients, the more sophisticated ones, actually there are only two, but will also take care of managing a cache for you. which means that they're not only fetching the data, but once they receive the data, they also put it into a store, and they make sure that you don't fetch redundant data if you already have it in the cache. And the most popular GraphQL clients at the moment are Relay, which is the homegrown GraphQL client from Facebook. And Relay really is like very, very powerful and highly optimized for performance. But on the other hand, it also comes with a really notable learning curve, and it's not so easy to understand, especially when you're a GraphQL beginner and you don't really know GraphQL yet. It's maybe not the right choice to start out with Relay, because it can be hard to actually distinguish what is the code that I'm writing for GraphQL now, what is the code that I'm writing for Relay, because it's very deeply integrated with one another, and it's hard to have like a good understanding which belongs to what. Then we have Apollo Client, which is like a much more simple alternative that I'm going to use in the demo as well. And then you also have GraphQL Request, which is essentially just like a lightweight wrapper on top of fetch. If you, for example, if you write a script or something like this, then a GraphQL Request would be the proper choice. If you build a more complex application with React, for example, then you probably do want to use one of these other GraphQL clients here. Quick look at the UI that we're going to build. So this is a pretty standard chat UI. The names of our chat users will be random, essentially. So I have like a small library that I'm using to get the names. And then we'll store the user ID and the username in local storage. And then the users can chat. And here are the different React components which we're going to use. So the whole thing is the chat component. And then in there, we have the chat messages, which are only going to render the list of individual chat message components. And then on the bottom, we've got the chat input. But we're really only going to take care of the chat component, which is where we put all the logic. All right, so now it's actually demo time. And I'm not going to attempt to do any like real life coding. Instead, I have prepared all the necessary steps, and I'll just paste them in, and then I'll explain what's going on. I think that's a bit more of a feasible approach for live coding. All right, quick look at the package JSON. We've got two dependencies. One is the React Apollo package, and the second one is the subscriptions transport WebSockets packages. So React Apollo contains all the functionality that we need for Apollo client, and then subscriptions transport WebSockets is what we use for subscriptions. The app is already implemented in a way that it already fetches all the messages from a backend. Let's take a quick look at the chat component right here. So here at the bottom, I've got this all messages query, which effectively we also saw previously on the playground. Here I pass also the last parameter, so if we've got more than 100 messages, we'll only fetch the last 100. And then what I'm doing down here is I'm wrapping my chat component with this all messages query using this GraphQL higher order component. So this GraphQL higher order component is coming from the React Apollo package, and this works because it's kind of similar to the setup that you have with Redux, where you also wrap your whole app with the Redux provider. Here I'm wrapping it with the Apollo provider, and the Apollo provider gets passed as a prop an Apollo client, and the Apollo client knows the GraphQL endpoint through a network interface. So that is like the rough setup. What you have to remember from this is that we have this Apollo client, which knows our GraphQL endpoint, and that the Apollo provider gets injected the GraphQL client. And then here again, we've got the GraphQL higher order component. And what is going to happen when this component is mounted is that essentially behind the scenes, the Apollo client instance, which I just mentioned, is going to send the request to our API. It'll receive all the data, and then automatically the data is going to end up in our props. So we don't have to use fetch, maybe inside componented mount or something. It's a very nice way of fetching data, because all we need to do is we write a query, we wrap the query with our component, and the next step is we're accessing the data of the query inside our component props. So let's see that in action. I'm going to start the application. Of course, we forgot one thing, and that is we have to tell the Apollo client what is our GraphQL endpoint. So I'm just going to copy it from here and paste it into index.js. So now our Apollo client actually knows which API it needs to talk to, and immediately we see the results. All the messages which we created in the playground before are now being rendered on the screen already. So the functionality that we now want to implement is that we want to be able to send messages, and we also want to see these messages appear in the chat in real time. Because at the moment it's a very, very useless chat. Nobody can essentially chat with each other unless they are using the direct API. So the first thing that we want to do is we want to create a user when the app is mounted initially. And the way how we're going to do this is by adding a create person mutation to the bottom of the app.js file right here. So here we're just using essentially the same mutation that we also saw in the playground again. We're passing in the name as a query variable. And then we have to export the mutation in the same way that we did before with the query. So again, we're using the GraphQL higher order component, and we're wrapping our app component with the create person mutation that we created right here. And what this is going to do, it'll make this mutation available as a function that we can call inside the props of our component. So it's not injecting any data, but it's injecting a mutation function that we can call through the props of our component. And then we're going to call this mutation right here inside component did mount. And the code for that is very, very simple. So if we don't have a name in local storage yet, we will just get a new name, and then we'll send this create person mutation where we pass this name as a variable, and then we wait for the result and put the data into local storage. Okay, we also need to import GQL and GraphQL, so let's do that as well. And now, if I run the app and also check the log, we already see that the user was created. And I can type, but we only see this in the console because we haven't implemented the create message mutation yet, and also not the real-time aspect of it. So let's do that next. We're taking the create message mutation, which I prepared, which you also already saw in the playground. And we're putting it into the chat component right here. Now we need to wrap our chat component with two different queries and mutations with two GraphQL operations. So for that, we can use Apollo's compose function, which looks like this. Here is the all messages query from before. And then we also add this create message mutation. And this now works in the same way as the create person mutation before, that now a function is injected that is called create message mutation that we can call to create a new message. And we also have to import the compose function so that this works. Next step is to call this function. And this is what we're going to do inside the onSend method right here. So here we're calling this create message mutation, and this is called create message mutation because we are passing this as an parameter here into the GraphQL call. If you did not provide a name, then it would be called mutate by default. And the same for query. If you don't provide a name for that, then instead of accessing this props all messages query, you would access a prop that is called data. But as soon as you have multiple queries or multiple mutations, you're pretty much forced to provide the name. Okay, so now we implemented the create message mutation, and let's go ahead and test it. All right, the message got sent. It doesn't appear on the screen, but if I reload now, we actually see it appear on the screen. So the last bit of functionality that is still missing is the real-time functionality. We want to see the app update in real time when a new message is received. And that is what we're doing with a GraphQL subscription. So the next step is to first reconfigure our network interface with subscription. So we have to go into index.js again, where we instantiated the Apollo client, because now the Apollo client also needs to know about the WebSocket URL that provides the connection to our GraphQL server. And the way how we do this is by importing the subscription client right here. Oops. From the subscription transport WebSockets package, which I showed before. And then we need to enter this subscription URL, and that we can get with the GraphQL CLI. So I'm going back to the terminal, back where I created my GraphQL server. And I called the gc info command before, and this is going to display all the different API endpoints that we generate for you. So here I'm just taking the one for the subscriptions URL, pasting it in, and instantiating the Apollo client. And now we have to use this to adjust our network interface and tell our Apollo client that we now have subscriptions as well. So this is what it looks like. We take the network interface from before, use the add GraphQL subscriptions function, and then combine the subscription clients, which knows our subscriptions endpoint, with the network interface and passing this into the Apollo client. So now we can use subscriptions as well. And now we only need to implement the subscription. So that, again, we're doing inside the chat component. And I've prepared the same or a very similar subscription that we saw on the slide before, except that the selection set here also contains the information about who created the message. And then I also provide this filter here, which essentially means that this time we are only interested in created mutations, but not in updated or deleted mutations. So this subscription on the front end is only going to fire when we create a new message. So this is the subscription, and now we have to use Apollo client to actually use it in our chat component, and we are going to set it up inside component.did.mount. What we'll do is we'll call this subscribe to more function on the all messages query. So this, again, is the all messages query that we got from here. So we tell the Apollo client that we want to subscribe to more data from that particular query. We're passing in the new message subscription, which is this thing up here. And then this update query function, which we're specifying, essentially works in the same way that a Redux reducer does, in that it takes in the previous state of the query and the data that we just received for the subscription, and it's going to merge that and return essentially the new state for the query. So it appends the new message that it received to the previous state, and then returns the updated array. So let's go back to the browser. I'm going to reload one more time, and we see the app updating in real time. All right. So now, as a quick bonus, in the end, I also want to show you that GraphQL subscriptions not only work on the front end, but you can actually also use them on the server side with GraphQL. So now we're talking a bit more about server-side subscriptions with GraphQL. What they essentially are is that when the event occurs in the backend, you can connect a serverless function. And if you don't know what a serverless function is, you can think of it essentially like a microservice, but it's only a function, so it's not like a whole maybe REST endpoint or something like this. It's just a function that you can invoke through an HTTP endpoint. And the input type for that function is determined by the subscription query. So in the same way that we just use the subscription query to tell the server what is the data that it sent over, we can also tell the server we want to receive this data as input for our function. And it's configured in the GraphQL.yaml file that contains your project definition. And I want to give one quick example for that, and the use case will be that we are going to spy on the chat now, and whenever a message with a forbidden word is received. Then we want to send out an email to one of you guys. So this is the audience participation part. I need an email from some volunteer. We'll do this in a bit, but first let me show you how the setup works. So here we've got the GraphQL folder, which I'm inside the terminal here as well. And let's take a quick look at the GraphQL.yaml file. So here we have the project configuration for our GraphQL project. We tell it that our data model lives in the types.graphql file, which I have modified before with the person and message types. And then we've got this functions part here, where in the beginning we provide like a default function for you that you can use as a hello world. But we are going to change this hello world function, and we're going to make a subscription out of it that is going to implement the functionality that I just mentioned. So first I'm going to rename it from hello to detect word. Refactor, thank you. And we'll also call it detect word here. And then what we have to do, we have to say that this is not a resolver function, but instead a subscription. And instead of a schema, we need to provide a query that we need to define in here. And this query is simply the same subscription query that we were using in the chat component. So I'll just copy it into here. And this now determines the input for the function that we are going to write in detect word.js. Let me quickly copy over the code for that function. So here I'm using the Mailgun API. You can see the private key. It's just a test account, so feel free to do whatever you like. So the code for the code for the function looks as follows. At first, we are retrieving the text from the message, and again, we're following exactly the same structure of the subscription query. So at first, we've got the root field called data, and then we've got the field message node.text, which corresponds to the query that we have here, message node text. And now we want to check if this message includes a forbidden word. In my application, this is going to be REST for RESTful APIs. So, and if that happens, then we can define this receiver email here, and then we'll just send a message with the subject launch the missiles and tell the user or the receiver that the forbidden word was used. So who wants to provide their email address so to prove that I'm not cheating? Anybody? I can send it to myself. Okay. Okay, it's just from my tests before, so it used to work. But let's go ahead and add my email here. All right, so, and essentially all we have to do now is we call GraphQL deploy again to tell the server that we have made an update to our local project definition. So it says that a new subscription with the name detect word is created. So now it knows about this function. And I can actually also inspect the logs using the logs command and pass the name of the function. This detect word corresponds to the name of the function in the GraphQL YAML file. So we can inspect the logs. And I have a couple of console log statements in here, received message, and then we'll either tell in the logs if it contains a forbidden word or not. Okay, so all we have to do is we have to go back to our chat and write something. I like GraphQL. I don't expect to get an email from this one, but what about I like REST? All right. Let's wait a second. There you go. The forbidden word REST was used with the message I like REST. And we can also check the logs. And it says received message I like REST. The message I like REST contains the forbidden word. And the previous one was received message I like GraphQL. This is okay. I like GraphQL. All right, to close off, I have a couple of recommendations for resources for you. And the first one, if you want to get started with GraphQL, there is the How to GraphQL full stack tutorials with like a basic introduction to GraphQL, and then a number of front-end and back-end tutorials for all major technologies and programming languages. So if you want to implement your own GraphQL server, you can do that using this website, for example, with Ruby, or of course with Node and JavaScript, but also with Python. And on the front end, we've got tutorials for React and Relay. We're going to add one for Angular, for Vue.js, so a couple of front-end technologies that you can choose from. Then we also have the GraphQL weekly newsletter, which you should subscribe to if you want to stay up to date about what's happening in the GraphQL ecosystem, and the GraphQL radio podcast, if again, you also want to stay up about everything that's happening in the ecosystem. Finally, we are hiring, so if you want to work with GraphQL on a daily basis, then you can check out our jobs page or send me an email. And this is all I have. Thank you. Any questions?
How well do the subscriptions scale if you, say, want to have 50,000 people connecting to a subscription and you have some kind of real-time service?
So that, of course, depends on the implementation. I would infer from your question that you're asking this about how they scale when you're using GraphQL, because if you're just using GraphQL subscriptions, it depends on your own implementation, on your own GraphQL server. With GraphQL, we didn't have any problems so far. I can't tell you exactly like what the numbers are, but what's really important for this is that we have the distinction between the hosted version and the self-hosted version. So if you're choosing the self-hosted version of GraphQL, you're essentially in control how many or how much hardware you actually want to put on that, and you can actually control this a little bit yourself.
Hello, thanks. Maybe my question more about Apollo, but is there a way to subscribe not in a component lifecycle, but more like in a higher order component or so?
So to subscribe in a higher order component, I don't think that is possible at the moment. So I think they only provide this API that I showed you at the moment with the subscribe to more function. I don't know that there is another way to subscribe to a query.
Okay, thanks.
In the front?
Thanks for your presentation, amazing. I think a couple of years ago it would take a month to build something like this. It's amazing. How do I convince my boss or my backend developer to switch to GraphQL?
Show them this presentation? I don't know. Yeah, it's a really good question. I mean, it's still a very new technology, and how do you foster adoption for this? I think that the hype around GraphQL is actually like really justified. It is a huge step forward in API technologies. Just try to, I mean, it's you have to explain it from like the front-end perspective and say how much easier it makes the life as a front-end developer. And this should also be relevant to your boss in terms of like the business, because if your front-end developers are more productive, they're putting in less mistakes into the code, less bugs, that's also like a really, it's a value that you can also monetize. So this might be something that you could tell your boss as well. More questions?
Hi. As a front-end developer, how easy would it be to implement a client-side GraphQL endpoint if my back-end developers don't want to cooperate just yet, if they're not quite convinced?
A client-side GraphQL endpoint? What exactly do you mean by that?
So that I can implement GraphQL in my app without relying on the back-end developer to do the work to create the endpoint.
So you want to have like a GraphQL API, but you don't want your backend engineers to do anything?
Well,
sorry.
or for some reason they won't implement it yet because they're not convinced, because whatever, you know?
Okay, and you still want to use it, but you don't have the GraphQL API in your company yet?
Yeah, so say I want to write my app using GraphQL in order to accommodate future, you know, because in the future it's anticipated that.
Okay, so you want to mock, like,
Pretty much,
maybe
yeah.
the API on the front end.
Exactly.
I think there are tools also provided from Apollo that you can use for that. I haven't used it myself, so I can't really speak to the details, but I'm pretty sure that there are like a couple of tools which essentially allow you to define your GraphQL schema, which also specifies what the API is going to look like, and then just like put in the values, and then you'll have like a mock GraphQL API that you can use. I can't tell you exactly what kind of tools you have to do for that, but I'm pretty sure that there are a couple of tools out there that are going to do that.
Which languages are provided for the serverless functionality?
Also, a very good question.
Can I write my functions in Java or Scala?
Yes. So the way how the serverless functions are integrated, you can essentially choose two ways how you can integrate one. The first one would be in the way that I just showed, where I just write the code directly inside a file and provide this as a handler for the function. But you could also specify a webhook. And a webhook essentially means you just provide the HTTP endpoint, and then you could implement this function yourself. So you could either write your own web server that implements the required logic, or you use like a functions as a service provider, such as AWS Lambda or Google Cloud Functions, where you can then take advantage of all the languages that they offer. So there you've got the flexibility. With GraphQL at the moment, you can only do it with JavaScript, but we actually also plan to support multiple languages, but it's just not ready yet.
Anyone else around here? No. Thank you, Nick.
Thank you. And one last word, I have GraphQL and GraphQL stickers, so if you want one, come find me. Thank you.
Okay, two things from my side. Our